You're still here? Well, welcome back to the Rule Your Pool podcast. This is episode 132. I'm your host, Eric Knight with Orenda and Hasa, and this is the first episode of 2024. We're about to travel, trade shows are going to get crazy, and I wanted to get this episode out before we get into the 3 months of trade shows that we have. In this episode, I'm going to discuss a different way of explaining our overall philosophy and how everything is going to plug into that in 2024. And that philosophy I'm calling Unnaturally Natural. Let's go. Welcome to Rule Your Pool, the podcast by Orenda that explains and simplifies pool chemistry so that anybody, regardless of experience, can understand it. I'm your host, Eric Knight, bringing clarity to these subjects so that you can bring clarity to your water. If you're ready to rule your pool, then let's go. In the last few trainings that I've done, I've found myself saying a sentence that just kind of came out of thin air initially. And that sentence is, water will always return to its natural state. Now, we've said this before, but I think that's a really important concept to think about because natural state for water is not clean. It's not disinfected. It's not sanitized. It's not chlorinated. Those are things that mankind does to water. We are the ones who filter water. We are the ones who chemically treat water. Water doesn't do that by itself, but water will balance itself. So the concept of returning to its natural state is a question as simple as this. If you were to abandon your swimming pool for, say, a month in the summer, what would that pool look like? It would probably look like my pool this past year before I did the green pool cleanup. It'll look like a pond because water returned to its natural state. Now, when I tested the LSI of that pond, it had a very high pH because there was a lot of algae in it, and algae consumes CO2 because they're a plant. So the CO2 is out of the water, very high pH, 10.4. The calcium was pretty low because whoever left it behind, but the LSI was actually balanced because of this very high pH. Water found its own LSI balance. I find that very interesting. As we know, based on the LSI, water can only balance itself one of two ways: eat or scale. Now, we can use the 6 factors of the LSI in multiple combinations. And as I've said before, a 6 factorial, meaning 6 times 5 times 4 times 3 times 2 times 1, is 720 different combinations. Multiply that by the amount of numbers on every dial of the calculator, and you literally have millions of ways that you can balance the water. Water has 2, eat or scale. So if water naturally returns to its natural state, it's going to have a very high pH. It's going to do what it can so that it gets back to equilibrium. Henry's law will help with this, but water will stop when it gets to its natural state, and then it will stop changing because it's happy there. There's 2 disciplines in water chemistry. There's water balance, which is the LSI in physics, and Henry's law, all that. And then there's water quality. This is what mankind does to water: disinfection, sanitation, filtration, making sure the water is safe, clean, and clear. We don't just need water balance. We need water quality. We need both. We really do. Now, if you were to prioritize one or the other, water quality is more important because it's a health thing. But if we let water balance itself naturally, the pH is going to be way too high. And you might be thinking, wait, Eric, we've heard you in so many episodes before telling us that you can have a pH go higher because you have CYA. The pH does not control the strength of chlorine. And I have said that. I'm not taking that statement back. I'm just going to clarify it. The issue with letting your pH go too high, and that's above about 8.3 is where it starts to become a measurable problem. If it gets over 8.3, 2 things happen. Number one, at 8.3, bicarbonate ions become carbonate ions because a hydrogen leaves. And when you have free carbonates, which is CO3 2-, meaning 2 electrons on it, it's going to bind to calcium in the water, and you're going to start to get clouding and scale because calcium carbonate is now coming out of solution. You can see this in an extreme example if you put soda ash into a pool. Soda ash is sodium carbonate. You introduce those carbonates and they cloud up, right? That's an LSI violation being forced. If your pH gets over 8.3, that can happen too. Now, it's not as dramatic as soda ash because soda ash's pH is closer to 11, but it is going to start to create some scaling issues if you're not careful. So that's the first reason we don't want to go over 8.3 pH. But the bigger reason is not water balance, like we just explained. It's actually water quality. When the pH gets high enough, the chlorine that you have in your water even if you have CYA, it starts to break away from cyanuric acid. And you really start to notice it over 8.3. I know it starts a little earlier, but you don't really notice it because it's such a small amount. But over 8.3, you start to notice that chlorine is leaving CYA in the hypochlorite ion form. Now, we talked about this. If you go back to episode 128, it's called Alkalinity's Complicated Relationship with Chlorine. And by the way, if you have the Orenda app, pull up the calculator, tap the hyperlink for CYA, and look at that chart. Zoom in on the right side of it and look at the bottom right corner of that chart. You'll see how the yellow and green lines curve up. And then you look at the purple line at the top right, and it's curving down proportionally because the protected isocyanurase, meaning chlorine bound to CYA, are going down, which means chlorine's leaving. It starts to break away and it'll get destroyed by sunlight. And if that happens, you won't be able to maintain chlorine. And if you can't maintain a chlorine residual, how are you going to keep that pool disinfected? Now, sure, you may have a secondary disinfection system. That's awesome. I hope you do. But that doesn't create a residual, and you need a residual sanitizer in your water to maintain disinfection. Now, I know there are some people that use chlorine alternatives, but you get the idea. We need a residual sanitizer at all times. I'm big on that. We don't want to over-chlorinate. We want to properly chlorinate. We want to have our water as close to pure as possible while keeping it safe, clean, and clear, right? We want to keep it disinfected. So here's what unnaturally natural means. We know from a physics perspective that water is always going to try to get to its natural state. And from a water quality perspective, a pond is not disinfected. A lake is not disinfected. So if we just abandon the pool, it's going to look like a pond or a lake. You're going to start having frogs eventually, tons of algae, all sorts of stuff. We don't want that. So we want to have water in its natural state, but we have to do it in an unnatural way, because if it naturally gets to its natural state, the pH will be too high to hold chlorine, the sunlight will get rid of it, and you'll have a pool that's not disinfected. So here's what we want in our philosophy. We want to get water into LSI balance on our terms, which is unnatural for water. But water doesn't care, because as long as it's balanced and it will stay there. If we are compliant with both LSI on the water side and Henry's law on the air side, which means our pH ceiling, when it's there, it's still LSI balanced, water remains in its natural state as long as we don't overcorrect with acid. So that satisfies water balance. Water quality, so if our pH ceiling is below 8.3, chlorine stays bound to CYA on these outdoor pools, and we are going to be able to hold chlorine a lot easier. Now, again, this is for private residential pools. Commercial pools, you're going to have a chlorine feeder most of the time, and that's a good thing. That way you're constantly feeding chlorine as you use it up, because your bather loads are so much more intense. The philosophy that we teach can be boiled down into our 4 pillars. If you have not taken Orenda Academy, you can go to academy.orendatech.com. You've got the basic Orenda Academy, and then you have the more advanced chemistry class called 4 Pillars. Credit out to Kirk Wisbaum on coming up with these 4 pillars with me. It was his idea initially to distill our message down into 4 action steps. Pillar number 1 is maintain LSI balance year-round. That's the action step. Pillar number 2, supplement your chlorine against the oxidant demand, because chlorine was not made to oxidize. It will, but it wasn't made to. It was made to kill. It was made to sanitize and disinfect. It's really good at that. It's not so great at oxidizing. Though it'll do it, it wasn't made to get rid of sunscreen, lotions, hair gel, deodorants, that kind of thing. Pillar number 3 is keep your phosphates below 500 parts per billion. And pillar number 4 is keep your cyanuric acid 50 or less on a residential pool, 15 or less on a commercial pool. You want some on an outdoor pool, but you don't want to overstabilize. That's the bottom line. You definitely want some CYA in your pool if it's outdoor, protect the chlorine from sunlight, because it's a really good thing. But too much of a really good thing becomes a really, really bad thing. The more CYA you have, the slower your chlorine. So if you just obey those 4 pillars and those 4 action steps, you will have water that is unnaturally natural, and it will behave. It's a pretty amazing thing. But I'm not advising you, and never have, never will, to put LSI before disinfection. No, disinfection is more important. I care more about people than plaster, okay? But you can have both. You just can't have both doing it the traditional way. And the reason for that is simple. You're fighting physics. And not only are you fighting physics, but that physics is fighting you back to the point that you're not able to maintain disinfection. So it's a double whammy. If you want to win, let's go unnaturally natural. And we'll show you how to do it on this podcast and in our website. This year is focused on helping us all up our game. You're helping us by asking questions. You're telling us, what do we need to write about? What do we need to talk about? Thank you for that. Again, the email is podcast@orendatech.com. Our help center is ask.orendatech.com, ask.orendatech.com. You can submit a question if it's not in there already. This is very helpful for us. It helps us know what you need. That's making us better, and we want to return that favor. We want to make it better for you. This year, we are doing something big for everybody in the pool trade. We are integrating with several routing softwares, and I will announce them as they come live. It takes several months for them to integrate, so they're not quite ready. Last year, we had pool service software. They were the first one to do it, but there are several more in the pipeline that are integrating now. We're very excited about it because we want you to be able to use our calculator in whatever software you're using. These softwares are helpful, and they're getting better by the week. And we hope that you will consider using them in the pool trade because they help you forecast better. They help you get better. They help you balance water better. And you have a lot of them to choose from. We are remaining Switzerland on this. I don't really particularly care which software you use, but I will say using software is a really good thing. We want to allow our calculator to be in all of them, anybody who wants it. And if that's the case, you're going to be able to get accurate chemistry readings and LSI in everything that you do. And that way, you will be able to store your readings. That's a big question we've had. People have not been able to store their readings, and it's just not something that we're carved out for. That said, I think that's enough for episode 132. This is going to be a big year, and I want to apologize in advance. We usually try to get one of these out a week. There's just no way. For the next 3 months, we're going to be able to do it every week. I'm going to hope to get out at least 1 or 2 a month. But again, we have trade shows pretty much every week. I'm sorry in advance for that. Please be patient. But once we're done with those trade shows, we're going at it. So thank you all so much for listening to this show for whatever reason you do. And yeah, I don't know how to end it other than that. We love you. Take care.
Thank you for listening to Rule Your Pool, a podcast by Orenda Technologies. For more information on what we discussed in this week's episode, check the links in the description or visit www.orendatech.com.
I hope you find this show valuable enough that you tap that subscribe button and share it with your friends. You can also like us on Facebook and social media. And with our help, you'll be able to rule your pool without over-treating it with chemicals and wasting money. I'll see you next episode.